In this chapter, we will deal with the central part of an atom called nucleus, which is very small and dense with particles consisting of protons and neutrons. The emission of radiations from the unstable nuclei is described. The process of fission and fusion, which are enormous source of energy, are also discussed. It has been discussed in previous classes that the nucleus of an atom is made up of protons and neutrons. The neutrons was discovered by James Chadwick in 1932 and was found to carry on no electrical charge. The protons carry a positive charge and therefore the nucleus of an atom is positively charged. The charge of the charge on proton is 1.6 multiplied by 10 and opposite to that of an electron. The atom as a whole electrically neutral, then number of proton in the nucleus is equal to the number of electrons around it. It has been determined that the mass of a proton is nearly equal to the mass of a neutron, which is equal to 1.67 multiplied by 10 kg. The protons and the neutrons in a nucleus are collectively referred to as nucleus. The mass of each nucleon is about 1835 times greater than an electron. Thus, the mass of an atom is mainly due to the mass of nucleus, that is, the mass of its protons and neutrons. Due to the mass of the number of protons in the nucleus of an atom is different in different elements and is called its atomic number. It is denoted by the letter Z. The number of neutrons in the nucleus is denoted by the letter N. The total number of protons and neutrons in a nucleus of all atom is called its atomic mass number, and it is denoted by the letter A equals to Z plus N. An atomic nucleus with a given atomic and mass number is written as, where X is any element. For example, a uranium nucleus of mass number 235 and atomic number 92 is written in shorthand notation as, and helium nucleus of mass number 4 and atomic number 2 is written as. Here the chemical symbols U and He are the symbols for uranium and helium atoms respectively. For a neutron, the symbol is used. Experimental measurements show that the nucleus is very small in size and occupies a spherical region in space. The diameter of a nucleus is of the order of which is 10,000 times smaller than the diameter of an atom and depends on atomic mass number. The nucleus are clustered together as incompressible pieces of matter in the spherical region of the nucleus. Elements which have mass number greater than 82 such as plutonium, radium, uranium, etc. are unstable by nature. These elements all the time emit different types of powerful radiations. This phenomenon is known as radioactivity. The atoms of these elements, as a result of emission of these radiation, undergo undergo a process of decay and they gradually transform atoms of one element into another. Radioactivity is an irreversible process which continues all the time as it is an inherent and natural characteristics of radioactive elements to radioactivity exhibited by these elements is known as natural radioactivity. Radioactivity was discovered accidentally in 1896 by a French scientist, Harry Becquerel. He was studying some compounds of uranium which glow in darkness when irradiated by ultraviolet rays. He wanted to know whether these compounds emit X rays. For this purpose, he performed the following simple experiment. He wrapped a photographic plate by a black paper in such a way that it was not affected by sunlight even if placed in direct sunlight for the whole day. He placed some crystal of uranium salt on this plate. On developing the plate, an image of uranium salt crystal was found on it. Becquerel repeated this experiment by placing a thin glass sheet between the uranium salt and the photographic plate. He found the same result by similar experiments. Becquerel concluded that uranium emits such radiations which can pass through black paper and can affect photographic plate. For further confirmation of paper can affect photographic plate. For further confirmation of his findings, Becquerel performed several other experiments, and from each he concluded that very powerful radiations are emitted from uranium, and any special physical or chemical condition of uranium is not essential for this activity. Emission of invisible radiation from uranium and other substances is known as radioactivity, and the substances emitting such radiations are called radioactive. Soon after the discovery of radioactivity, Rutherford and other scientists found out that radiation emitted from radioactive elements are of three types named as alpha, beta, and gamma rays. These can be separated by a simple experiment. A small quantity of radioactive substances such as radium is so placed in a cavity in a block of lead that the radiations from radium can come out of the mouth of this cavity. A photographic plate is placed at some distance above the lead book block so so that the radiation from radium fall upon it. This apparatus is placed in a vacuum light chamber which is evacuated by a powerful pump. This chamber then is placed between the poles of strong magnetic field is perpendicular to the plane of paper is directed inwards. Under the action of magnetic field, two of the three types of radiation are deflected, so three separate images are formed on the photographic plate. This shows that radiations coming out of radium are of three types. One of these are those radiations which bend towards left and give rise to black spot on the plate close to the center one. The direction and extent of deflection shows that these radiations consist of positively charged particles which are quite massive. Further experiments shows that these particles are nuclei of helium. These radiations are known as alpha rays.